Welcome to Science Unwrapped. We are so tickled to have you all here. I am Boyd Edwards. I'm representing the Science Unwrapped committee to welcome you here. And it's my pleasure to introduce Patrick Belmont, my friend. When Patrick isn't running Green Canyon, he's busy being a professor here at Utah State University in Watershed Sciences. He has research interests that span a variety of sciences from hydrology, that's the math and the physics of water, and geomorphology, which is, I'm a physicist, so I have to look these words up. That's how the Earth's surface is shaped and changed with time, as well as ecology and climate science. So throughout his career, he's been exploring how all these different pieces fit together and what they mean for humans and the world we live in. Patrick has published over 60 peer-reviewed publications and has been awarded over $12 million in research funding. Among his awards and honors, he received the Kirk Bryan Award for Excellence from the Geological Society of America, the Utah State University Faculty Researcher of the Year Robbins Award in 2018, the Utah State University Sustainability Award in 2019, and he has served as president of the Faculty Senate, USU Faculty Senate, in 2018 to 2021. All of us have homework to do, so hold your pieces of paper and your pencils up. If you don't have a piece of paper, then there are folks up at the top. Lisa, can you help with those? Raise your hand if you don't have a piece of paper, because this is a mandatory homework assignment situation. Am I right, Patrick?
It is.
About that.
It is.
So, yes. Oh, another one here. So welcome, Patrick. Turn the time over.
Welcome. Thank you so much for being here. Yeah, if you don't have a piece of paper yet, just keep your hand up and they'll get around to you. Well, I am so excited to be here. Thank you all for taking the time. We'll have some fun and we'll learn some new things. We're going to talk about, can we live the good life and keep our planet healthy? Big question. We're going to know the answer to that by the end of this, okay? I love science. I do lots of science, but I don't just do science. So I just wanted to start out real briefly, letting you know I'm a person. I love to do lots of other things. Lots of running up in the mountains there. I love to be tromping around in any kind of rivers, muddy or otherwise. I've taken to backcountry skiing. I had a beaver pass the last couple of years, but now I just love going out in the backcountry and skiing. So I love doing a lot of that. I've got an amazing, almost 15-year-old daughter who would have been here, except she's doing her first debate for Logan High tonight down in Salt Lake City. So that's exciting. And when I'm not doing any of those things, I love to cook. That's my other passion. This is my patented s'moreberry, perfectly roasted marshmallow, dark chocolate, and I always felt like the graham cracker was the weak link, so replace that with a slice of strawberry. But that's me, and here's some pasta. I love to make pasta. I had kind of a long and meandering path to where I am now as a watershed scientist. So I wanted to briefly share that with you as well. I started out in college studying these little microscopic worms, and the worms lived to different ages. And we were trying to figure out why they lived to such different ages. And we were doing some genetics work that helped us figure out the things that are controlling how things age. And I was working with this guy, Phil Hartman. And then, one of the things I learned from that is I love doing science. I did not want to spend the rest of my life staring at a microscope. That was too much. So I ended up taking classes from a couple other people who worked outdoors. And I thought, well, I can apply some of these genetics things that I'm excited about to understanding how to manage the environment better. And so they were big influences on me then. I went and did a master's and PhD out in Pennsylvania and was studying lots of rivers like this all out across eastern Pennsylvania. looking at a variety of things there, but mostly ecology, the interactions of living things. But then I kept going running with this guy on the left, and I took one class from that guy on the right, and they're both geologists, and they both kept showing me that so many of the ecological things I was interested in were being driven by the geology of the landscape, and so I started getting interested in that. And then I went to Minnesota, and I started studying these muddy rivers, and we're trying to figure out where does all that mud come from, because it's way above what the EPA standards allow. And there's corn and beans there, but there's also some of these big banks you can see in that photo there. It turns out that's kind of a difficult question to ask, but to answer. I was really fortunate to get to work with these people, a bunch of engineers who see the world through a series of equations. And they pulled me over into this very beautiful mathematical world, and I pulled them over but wait, I'm out in the field and I'm seeing all this cool stuff, and we need to make sure that's in the equations. And so we did some big things there that changed the way we do conservation in the upper Midwest. And I'm really proud of that work. But I just feel so fortunate, 20 years into this career, to have gotten to work in such amazing places in the world. The Olympic Peninsula, Death Valley, the Appalachians, Oregon, Taiwan, wildfire throughout Utah and lots of other places in the West, Bear Lake, out in the Redwood Forest out in California. I'm just so lucky to have been able to do all this work. But that's not what I want to talk about today. I could talk about any one of those stories, and there's lots of fun stories in there. But I've kept meandering and broadening my interests, and this is what I want to talk about. What do we really value? What does the good life mean to you? And can we keep living it while keeping the planet healthy? So here's where the homework comes in. I want you to just take a minute and think about 5 things that make your life better. And just write those down. It can be anything. And then I'm going to ask you to write just 2 or 3 things that make your life a little bit harder, a little more challenging, worse. So a couple things that make your life better, a couple things that you're not super happy about. And you don't have to share these. I'll ask a couple of people to share if they want to, but these can just be for you. So, and we'll keep coming back to these throughout the talk. Okay, getting through those. You guys are a great audience. I can see everybody working on these things. I love it. You're awesome. All right, you can keep working on those, but we'll keep going. There's so many things that we might think of that make our lives better. And we've got cars that can get us all over the place. Ice cream undeniably makes our lives better. We've got medicine. We've got a tremendous amount of medicine that when we're sick, it's going to make us healthier. Books. Does anybody remember books? When we used to use those? Yeah, books make our lives better. We should read more books, I think. We've got these little tin cans that we can get in, and they go 35,000 feet in the air, and they can fly us all the way across the world. It's amazing, right? We've got Lucky Slice pizza. We've got donuts. Taylor Swift. So many things. So many things. I see a no up there. My daughter just told me Taylor Swift is now a divisive issue. I don't know how that happened, but anyway, you can put whatever musician up there that you like, but there's so many things that make our lives better, right? But what's the role of science in the good life? Science can tell us what is, it can tell us how things work, and that's really useful. But it can't tell us what we ought to be doing with that. Science and engineering have brought us so many things, but it's really up to us and our values to decide what to do with that, right? Science can't tell us what we ought to do. We're going to keep coming back around to that through this talk. So, as I was thinking about lots of good things in the world that I really enjoy, and then lots of challenges that I'm working every day to try to solve, I started talking to some of my friends around campus here, other faculty, and was saying, we're really talking about these things in very different ways across campus. And we should probably get together and have a real conversation, a hard conversation about how these things can be working better. And so I was just elated that the more people I talked to, the more people wanted to be part of this conversation. And so we started this thing called the Dialogues on Economic Growth and Sustainability. And it's a 3-part symposium that happened this February. And a lot of what I'm going to talk with you about are things that we figured out during these dialogues on economic growth and sustainability. So that's fun. I'm really indebted to all these people for having contributed to this conversation, coming from all walks of life, all different parts of campus. Okay, here's a question session. I just threw out 2 terms, economic growth and sustainability. What does sustainability mean? Anybody want to try to define sustainability? What do you think?
The ability to maintain our current lifestyle while also protecting the future lifestyle of our future generations.
I like it. Everybody hear that? Our ability to continue to do the things that we need to do while protecting future generations as well. Love that definition. Nailed it right away. It's a good audience. What is the economy? Somebody want to define what the economy is? I'm really good with awkward silences, so I'll wait. What is the economy? We're talking about economic growth.
It's an imperfect system for getting goods from where they are to where they're needed.
Interesting. I like that. Gail, well done. Yeah. A lot of people think about it just as money, and it's money moving around. But money is the only thing that's not actually real in our economy. And so if that's what immediately came to your mind, is that the economy is about money, consider that. Money is the only thing that we completely made up, right? We made it up. So we're going to get to the importance of that here in a second. So here's basically just sketching out what Gail just told us, a sketch of the economy. We've got companies, we've got people. People pay companies money for goods and services. People provide labor, and the companies pay them, right? So it's this big circular thing of money moving around, goods and services, work. You've got the government in there that takes taxes from both of those and makes services and payments to those. That's the way a lot of people think about the economy. And it's a totally reasonable way to think about the economy. And I'm going to challenge you to think a little bit differently about it. But here's one place where I want to come back to this list you just made. How does that relate to some of the things that you care about? The things that either made your life better or make your life tough. How do you see those in here? Or are there things that you wrote down that you don't see in there? Lots of opportunities for volunteering here, so. Think about your list. How do things on your list relate to that? Yeah. They're mostly outside of that. Do you want to give any examples?
Unbroken natural areas, friends and loved ones, art and artists.
Oh, we'd be very good friends. I love those answers. Yeah, there's a lot of things that aren't considered by this, right? So let's think a bit more about those things. Anybody else want to offer something there? Yeah.
I was thinking about how our economy, we always go up and up and up. More, and we need to
Yep.
our markets need to go up to be able to satisfy all the demands that we have as a human race.
Yeah, we've got this push for the economy to go up and up and up and up. We're going to talk a lot about that over the next 15 minutes. I love it. Okay. How do we measure the economy? Anybody know? There are a couple of different metrics, but there's one that really most people look to. What's the main metric we use to measure the economy? GDP, right? The gross domestic product. So this is the number one metric that most economists look to. And I do want to, if there are any economists in the room, I'll just acknowledge that there are other metrics they look at, but this is the dominant one. So GDP, this is the only equation I'll show you, but it's just consumer spending plus investments we make, like in the stock market, plus government spending. And this is what GDP has done over the last 200 years, right? It's just gone up and up and up and up. And that's about a 3% growth rate that you're seeing there. And this is, different parts of the world. This economy, just like we were just talking about here, was designed to grow. And the reason it was designed to grow is because if there's more money in the economy, there'll be more spending. That means more jobs. That means more money. That means more spending. That means more jobs. Okay? And so economists have placed all these incentives, or helped us place all these incentives to just keep the economy growing at a rate of about 3% per year. That's kind of the magic number, right? And so we've been doing that for a long time. And, there is a narrative that that's how we lift people out of poverty. And there are some data to suggest that happens for some people in some places at least, right? So this economic growth cycle, that's why we've been doing it for so long, and we've been so loyal to it. But does anybody see a problem with continuing on that growth rate? Right? This has gone vertical, right? That seems maybe problematic. Let's see. Let's keep exploring that idea. Because I just gave you, this part of the economy. This is super fancy. Well, this part of the economy is what we were just talking about. But in reality, this is where the real economy happens on the planet, right? And so we've got all these resources that have to go into that system to make it work. And then that system's also producing a lot of waste. And we kind of throw things away, but there isn't really an away. Like it's going somewhere else, but it's not going away, right? So we can talk a bit more about how this exponential growth relates to these ideas. I just want to bring up the example of a cell phone. Now, if we think about a cell phone, this is a very common thing. There's a lot that goes into this, right? We're all carrying around computers that are way more powerful than the computers that put, astronauts on the moon in our pockets. It's an amazing thing, and we could look at this and say, well, this is part of the good life, that I can be connected, I can look up whatever, I can watch a Taylor Swift concert or whoever else right on my phone anytime I want. That's amazing. But when we think about all the resources that are needed for that, we have the casing, the battery, circuitry, speakers and microphone, the screen, and all those are made of different things, different natural resources. And they come from all different places, often, on multiple continents. And so to make plastic, right now, most of our plastic comes from oil. And so we've got to be pulling up oil and making plastic from that. All the metals we're mining, and those mines are enormous. We've got several right down by Salt Lake City, you can see. And they leave a bit of a mark, right? To say the least. And many batteries are made out of lithium. And lithium is another really intensive resource to extract. It leaves a bit of a mark, right? And so right now we're trying to electrify a lot of things. That means we need a lot of batteries. That means we need a lot of lithium. That's taking up a big space on the planet, increasingly, for mining it and extracting it. So all these things, even something as simple as a cell phone, it's making impacts all over the world in different places. And then where does all that end up? If you're like me, it ends up like in a drawer in your kitchen. I've got like 4 generations of phones in my kitchen. I don't know what I'm going to do with them. I'm going to try to get them recycled at some point. But, most of the time we're disposing them, and they end up in, most of them in Africa or Asia. And so that's part of this waste, a lot of toxic waste that ends up in places that are far, far away, but they're not away from everybody. There are impacts to people locally, and there are lots of costs associated with these wastes that we're creating at an exponential rate, right? So let's talk a little bit more about some of the problems we see in this economic system we've got right now. Why is the Great Salt Lake drying up? Anybody know? I know somebody in here knows. I know lots of people do. What's the number one reason it's drying up? That is one reason, but it's about 10 or 15% of the reason that it's down as low as it is. But moving forward, it's going to be a bigger challenge. But there's a bigger reason why it's drying up. Yeah, down here? Bingo. Water diversions. We're diverting 2/3 of the water that would otherwise get to the lake. Right? Only 1/3 of what would naturally get there gets there. And we're using about 75% of that for alfalfa. We use about 15% of it in our homes and for all the companies and industries in Utah. But interestingly, we've had a lot of population growth over the last 4 or 5 decades, huge population growth, huge growth in our economy in the state. And the water use by people and by companies is a flat line. It hasn't gone up at all. That's really phenomenal. Alfalfa is using about 75%. So to some extent, we're making a choice to grow a lot of alfalfa at the expense of the Great Salt Lake. That is essentially the choice that we're making, right? And so what are the problems with the Great Salt Lake drying up? I mean, it's just a big, stinky, salty hole in the ground, right? Yeah, there's a lot of nasty stuff in that dust. Lead, arsenic, zinc, things like that. We're breathing that. That's already causing problems, birth defects, cancer, things like that. What else? What other problems are there with the Great Salt Lake drying up? Yeah. It's getting too salty. That's Wayne Wurzbau, limnologist who has done a lot of work in the Great Salt Lake. There he is in the back. Too salty for the brine shrimp. Yeah. It hurts the ecosystem. There's 10 million birds. There's 350 different species of birds who rely on that. And as that dries up, we could lose some of those if we don't bring the lake back, right? There's 9,000 jobs that depend on the lake. We say something like $2.5 billion of our economy depends directly on the lake. There's a lot of things, a lot of costs to the lake drying up, right? And those costs are not part of alfalfa, right? We don't wrap those back into alfalfa. But an efficient economic system would say that's the way to do it. All the costs and all the benefits have to be wrapped up in the price of things that we produce. And so if drying up the Great Salt Lake is part of the cost of growing excessive amounts of alfalfa in Utah, well, the economist's answer is just to wrap those costs back in there. Well, alfalfa would go up to tens of thousands of dollars per bushel at that point. That's why we don't do it. But lots of costs of Great Salt Lake. Pollution from our cars is another example of one of these costs that's just not really counted. There's lots of pollution that comes out the tailpipe of our cars. We're breathing that. That's one of the reasons that Utah has such high asthma rates, especially among kids. That's a real cost, right? Kids are paying that cost. Moms and dads are paying that cost at 3 a.m. when they have to go get a ventilator for their kid. Those are all real costs, but we're not paying them at the pump. An economist would say, well, we should be paying that at the pump, then you can make a smart decision about whether or not you really want to pump gas into your car or not. And then this is one that, how many of you have heard of PFAS? Only a couple of you. So these are really concerning. These are forever chemicals. They're used in lots and lots of things. Nonstick cookware, shampoo, candy wrappers, food packaging, pesticides. We use these things in all kinds of stuff. And so they are everywhere now. We're finding traces of these in Antarctica, right? And it turns out that they are highly carcinogenic. And when we have estimated how much would it be to clean up the PFAS in the world, it's something like $100 trillion. That's a lot of money. It's an inconceivable, impossible amount of money, right? So there are lots of costs that come from this economic system that we have they're not being paid when we're making the transactions within our economy. They're getting paid other ways. They're catching up with us in our health and things like that. But economists have known about these things for a while. They're called externalities. They're costs that have been externalized from the price of something. And in some cases, they do say, well, we can estimate what that cost is, and we can bring it back into the price of something, and we can fix it that way. But a lot of them, we're not. We're not doing that right now. But this is something that economists have been working on, have been acknowledged for decades, and we're doing an okay job. But you could say, the good life, the side effects that are catching up with us, air pollution, water pollution, cancer, coughing, wheezing, habitat destruction, fertility problems, the list goes on and on and on. There's lots of these problems with our economy. These are all things that economists have recognized. There's thousands of papers on them, right? Papers don't solve problems, but they help. But the next couple things I'm going to tell you are things that economists are just starting to grapple with. And these are some of the really key things that we got to in this Dialogues on Economic Growth and Sustainability. So a 3% growth rate means that the economy doubles every 23 years. It gets twice as big every 23 years. That's what an exponential growth rate looks like. You can see it there. And you can imagine that keep going for another 23 years, it's going to be twice as high, right? But resource limitations and waste are already at pretty critical thresholds, right? We're already feeling a lot of the effects of these things. So how many more times can we double this economy on a global scale? And here's the other kicker. GDP growth and energy use are strongly correlated because any economic activity that we do requires energy. And so even if we get a little bit more efficient at something, we usually end up just using more of it. That's the thing that economists call Javin's paradox. So we get LED lights, that's great. They're a lot lower energy lights, but then we just put in a lot more lights. Or we start putting in AI data servers in southern Utah that have the same energy demand as the entire state of Wyoming. That's being proposed right now. So there's no free lunch with this. As soon as we make some efficiencies, the economy finds a way to use extra energy. So GDP and energy are both very, very strongly correlated, and there isn't a way to make them unlinked. And, I've been working on climate change for 20 plus years, and I've been, it's so hard, because I'm like, how is it that we haven't solved this problem yet? We had all the science we needed, certainly by the early 90s. We've understood the problem, we've understood what we need to do to solve it, and you can see what we've done in terms of energy. We've doubled the amount of fossil fuels that we use since that time, right? So this is global energy consumption from coal, oil, and gas. They're all going up. All the nuclear power in the planet is in that blue line there. And then all the renewables, every solar panel, every wind farm, every geothermal plant, every hydropower plant is in that green little band there. I'm working on making this my Halloween costume because this is the scariest graph I have ever seen because it just keeps going up, and it has to keep going up if we need GDP to keep growing up, right? And what it means is that every solar panel and wind farm on the planet hasn't reduced our use of fossil fuels at all. They've kept going up too. They've just enabled more energy consumption, right? So this is a really critical point. And it shows why it's been so hard to start turning the right direction on climate change. Okay? There's no amount of solar panels, wind farms we can put up to keep up with exponential growth. Okay? There is a very basic truth that if we can all accept, then we can start on the road to solving the problem. Okay? And then if you even want to think longer term than the next couple of doubling cycles, the laws of physics basically tell us we cannot keep doubling energy for a lot longer anyway, for reasons I won't go into now, but we can talk about the second law of thermodynamics makes that very clear. It can't happen. So a more fun aside about exponential growth, just in case you're not convinced yet that exponential growth is a problem, I need one brave person who's going to have to make a decision here. Who wants to make a choice? Okay, Cubs fan, I love it. Here we go. Your choice is, I could give you this bag of M&Ms today. It has 225 peanut M&Ms in it, because peanut M&Ms are healthy, right? And it actually only has 221, because while my daughter and I were counting them, we each ate 2, but it has 221 M&Ms in it. Or I could give you 2 M&Ms today, 4 tomorrow, 8 the next day, and we do that for 2 weeks. We just double it every day, how many I'm giving you. Which one do you choose? The bag today or going up, doubling every day? This is a smart guy. I like it. Yeah, at the end of the 2 weeks, do you know how many M&Ms you'd have? Do you know how many M&Ms you'd have at the end of 2 weeks? More than your parents would let you eat. I know that. 32,000, right? So at the end of 2 weeks, you have 32,000. I, of course, did the math to figure out how long it takes before we fill this entire auditorium. How many days do you think it takes to fill this entire auditorium with M&Ms if we keep doubling it every day? Give me a number. How long do you think?
2 months.
2 months. That's a really good guess. It's a little under a month, and we would fill this entire auditorium with M&Ms. How long do you think it would take before we had M&Ms that are the same volume of the entire Earth? This is going to shock you, but this is exponential growth. Somebody give me a guess. 1 year? 2 months? These are some good guesses. It's 79 days. In 79 days, we go from 2 M&Ms. In 28 days, we fill this entire auditorium. In 79 days, we have enough to it be the same size as planet Earth, right? Exponential growth is crazy, right? So let's get back to economics and think about economic growth, exponential growth. Why is this all coming to a head now? It's coming to a head now because we've essentially gone from a small world on a big planet. We had very few people who were using very limited resources to now we've got a pretty full world. We've got, 8+ billion people on the planet, and they're using a lot of resources. And we're feeling the effects of that, from the resource extraction side of things to the waste side of things. And we're being told over and over again, we just got to keep moving the system up 3% every year. Okay. So here's where we come back to living the good life. And here's my proposition. To keep living the good life, we've had material consumption going up, we've had energy consumption going up exponentially, we've had GDP going up exponentially. To keep living it, those have to come back down. There is no way around that. And so it's a matter of how does that come back down? A lot of Earth systems are very stressed right now. And so we're seeing ways that Earth systems are actually failing. And it's not inconceivable that those fail in a way that bring this down for us in ways that we don't really like. I'd rather be doing it by design. I'd rather be designing the way that we bring this back down. So let's talk about what that looks like. To do that, the economy isn't just something that's off in space. The economy is something that is well within society. We're making decisions about how it works and how it's serving us and the planet. And then we've got a hard constraint of the environment. And we're looking at that constraint very closely. So this is a new economic paradigm that's coming forward that I think solves a lot of these problems. And it's called donut economics. And I'm going to be done in about 5 minutes, and there are going to be donuts out there. Specifically, so you remember, we've talked about donut economics. So here is the donut. This is an economist's view of a donut, by the way. We should not leave economists by themselves to do these things, right? I would have picked a donut that looks more like that, but it doesn't matter. The green thing is supposed to be a donut, okay, as an economist sees it. And what they've put in that donut are many of the things that we care about, many of the things that you relate to things you probably wrote down: water, food, health, education, income and work, peace and justice, political voice, social equity, gender equality, housing, networks, energy. These are a lot of the things that we really value. And what donut economics is saying is, I mean, we can kind of forget GDP. It's not getting us where we need to go. Let's think about these things that we really value and make sure we're measuring them. And so in the inside of the donut, that's telling us how well we're doing on a global scale. The gray is telling us, on a global scale, how well we're doing. The red is showing our shortfall. So with food, we're doing pretty well. There's about 85 to 90% of people have access to the food that they need. With social equity, it's about 50%. And some of these have two metrics. That's why there's two of them. Other ones are just a single metric. But the goal is to get all those white or gray bars up to the donut, so there's no red showing in there whatsoever, right? The good life is in the donut. That's the tagline of this talk. The good life is in the donut. And here's the other side of the donut, our planetary boundaries. So there are things that we're doing that are exceeding the ability of the planet to absorb them. With climate change, with nitrogen and phosphorus loading, we're putting a lot of nutrients into rivers, and those are going down the Mississippi River, and they create a huge dead zone in the Gulf of Mexico every single year. That's something on the order of the size of the state of New Jersey. These are planetary boundaries that we're exceeding, and so we want to get those back into the donut. The good life is in the donut. And so just think for a second about how these things now relate. Maybe they relate better to some of the things that you wrote down about family and friends and time and health, and things like that, right? We should be measuring the things we really care about. That's how we get our economy working for us. So what does it actually look like? Well, we've got access to good, healthy food. Clean drinking water for us and for nature. We've got lots of these public spaces that we can go out and enjoy and get rejuvenated by. We've got friends and family and their health. And there will still be donuts. So no worries. And this is already being done in some places. Bhutan is frequently ranked as the happiest country on the planet. And the reason that this is a country that's right between China and India, very small country. But they threw out GDP a long time ago, and they said, we're going to create a gross national happiness metric. And this is the foundation of it: sustainable and equitable socioeconomic development, preservation and promotion of a free and resilient culture, and good governance and equality before the law, and then ecological sustainability. That's what they base all of their decisions on as a society. And it's working. It's the happiest country on the planet. So the good life is in the donut. These are just a couple of finishing thoughts here, and I'll entertain some questions. So now that I announced there's donuts, maybe I just want to go get the donuts. But the good life can look a lot of different ways, and I think it's up to us to be reflecting on what that good life really should be looking like for us and other people on the planet. One person living their good life can have negative impacts on wildlife and other people today and in the future, getting back to our definition of sustainability. And in the big picture, the energy and material consumption curves, they have to bend back down. That's the only way to get out of this exponential growth that's choking us. And we can do that by design, and we can do it in ways that make our lives better. And lastly, we should measure the economy by the things we really value. So thank you so much for being here. Hope that was interesting. And you're going to win a bag of M&Ms here if your parents are okay with it. Thank you. Okay. How are we doing? We're doing all right on time. Yeah. Question?
Patrick, when you talk to folks around town or across Cache Valley, around the state, places that you've traveled, do you ever hear our political leaders acknowledge that perhaps growth cannot be sustained, that it always has to be 3% or more? Do they ever acknowledge or speak to this? And I'm talking across the
Yeah.
whole spectrum.
So the question was, do we hear political leaders talking about economic growth not being sustainable at this rate? Early economists all were very clear in the writing that this cannot be a forever exponential growth. They were all very clear about that. And if you get an economist to really draw out what our future economic growth looks like, they start getting pretty squeamish, in the next couple of decades because it looks ridiculous. On the political side of things, and I don't want to get too much into politics, but this is not a popular thing to talk about. Because there's so many questions about how do we transition to a system that still has good, reliable jobs for people and is not reliant on this exponential growth curve? How do we plan for retirements, which are currently planning for an exponential growth curve under a different type of system? And what I'll say is that economists have worked out some of those, but they haven't worked out all of those yet. And that's because we don't have enough minds thinking about it. They're all solvable problems, but we have to get a lot more minds thinking about how do we make those transitions and maintain a really good quality of life. Because if you think about the alternative, we get there by design or we get there by disaster. On an exponential curve, those are our only two options. And I will always choose design, right? It's not an option to just keep going and just be okay. And we're feeling that now. We're already feeling that catching up with us. So we could start designing. Wayne.
Yeah, we have exponential growth in domestic product, but we also have exponential growth in the human population.
Yeah.
How do you reconcile those two?
Yeah, the exponential growth in human population is starting to slow down, but we have had a lot of growth in population. It turns out the planet doesn't care how many humans are here. So we have to manage our economy in ways, in our resource use, in our waste production, in ways that accommodate that. And so you can look at the equity of how people are using resources and producing waste, and it's highly inequitable right now. And that's why we have all that red inside the donut still, while we're also producing lots of red outside the donut. So we're not going to turn hopefully, we're not going to turn the population growth problem around tomorrow. If that happens, something really bad happened. But that curve is turning over, and it's just another thing that we have to manage along with all these other issues. We have to solve this problem within that context, or the planet solves it for us, right? And I don't think we want that. Question here.
So, can you offer 2 or 3 things, concrete things that we can do to help that curve bend over? Someone said maybe fly less because flying has.
Yeah. What can we do? Flying is one of the most. It's the most energy-intensive thing that probably any of us do. And I used to fly a lot. I used to fly 12 or 15 times a year because I was invited to conferences all over the place to present my science. And I've cut that down to just 1 flight per year for exactly this reason, because that's something that I can do. And I thought I was really going to miss it. And I miss traveling a bit, but my life's really good because of it. I have a lot more time at home. So there are lots of ways that we can reduce energy consumption. Driving really long distances is also very energy intensive. Developing in really low intensity ways. If we develop in really low intensity ways, just neighborhoods that are on 1 acre lots, everybody has to drive then, right? And it's locking us into decades more of really energy intensive living. And so I know it's not popular among everybody, but I love to see some of the density coming to downtown Logan, which is where I live. I live right downtown, because it means it's a lot more walkable and bikeable city. It means the mass transit becomes a lot more efficient, and these are all, big energy efficiencies. AI is a big concern right now. AI is incredibly energy intensive. And so how do we continue to use AI technologies while also bending that curve over? I don't have the answer to that question, but it's a really important question for us to be asking as a society. AI is very energy intensive. Yeah.
On that very question, Patrick, have you asked AI to?
I'm going to do that tonight. I will be asking chat. Yeah, it's great. So this is Bill Gates' argument for continuing with AI, is that it is going to figure out efficiencies that far outstrip the costs of it. And I can't say that he's wrong about that. I don't know. It's at least a reasonable rationale that in the short term, the benefits we get from AI could outweigh the energy costs of it. I'm open to that being a possibility. But it may not be too. Yeah, question up there. Say that one more time. Well, it's really about what we measure. It's not about necessarily wholesale changing the economy, but it's about paying more attention to what we measure and making sure that we're measuring the things we really care about and that we're optimizing for those, not that we're optimizing for GDP. GDP has made some people's lives better, but it's also made some people's lives worse. And in any case, it can't continue for a long time at this kind of growth rate. And so it's really about kind of being GDP agnostic. Like maybe GDP continues to grow a bit in the future, but let's really start paying attention to the things we care about and making sure we're optimizing those. We'll be in a much better place. Yeah. Awesome. Great questions. Yeah, say it loud. Sure. Yeah. Yeah, there are a lot of shiny things that our human brains get attracted to, that we want that, we want that, we want that, and we want 4 of them. And our brains are a little bit hardwired to look for shiny things, whatever they are, and to want them. And we push that a lot in America. America is a very high consumer society. And there's a lot of good here as well. There's a lot of those things I showed in the good life. We do them very well here in America. The problem is that part of the way that we have gotten to such a high quality of life in America is because other people have been taking up a large part of our waste. And we're getting to a point now where we can't keep doing that. In part because they won't let us, but in part because it's actually coming back to us now. And climate change is one big way that's coming back to hurt us. The economic growth model drove colonialism. It has driven a lot of decision-making throughout history, but we're feeling the effects of it now. And so that's why I think now is the time to start thinking about how do we do this differently? How do we do it better? Not just for people in America, but for people around the world. Because we're all connected. We are all in this together. There is no great planet. There is no international travel where, everywhere else is just our waste dump, right? So. There are donuts waiting. One more question. Ooh, how do fertility rates affect the good life? Interesting question. I mentioned fertility rates in here because they have been negatively impacted by some of the dust from Great Salt Lake. But, looking at different scenarios all around the world, I wouldn't say that there's any direct causation between fertility rates and living the good life or not being able to live the good life. It's a matter of how you manage it and how you manage the people that you've got and the resources. So, I really appreciate y'all spending time here. There's lots of fun activities and donuts out there. I'll stick around for a bit. I'm happy to answer some more questions. So, thanks.